Good morning, 10th class students. Today we are discussing about the non-metal chemical properties. Okay, and in this part we will discuss how reactions of non-metals can with the water, with the dilute acids, with the salt solution, with the chlorine, and with the hydrogens. Okay, so first let's should we have to discuss because in last video we already discussed about with the oxygen, and now we are discussing with the water. So reaction of non-metal with water. Okay, reaction of non-metal with water. So uh, there is a no reaction with water because generally non-metal non-metal gives sorry non-metal do not give do not gives electron to reduce the the hydrogen reduce the hydrogen ion from water. Okay. I hope you are understanding. It means reaction of non-metal with water. It means no reaction with water because generally non-metal do not give electrons. You know about that. Metals only gives electron, and non-metals generally accept the electrons. So non-metals do not give electron to reduce the hydrogen ions from water. It means from the water the hydrogen ions cannot reduce with the giving of electron. Okay, so they cannot form like with non-metal to water. There is a no product will be formed. Okay, next is our that reaction of reaction of non-metal with dilute acids. Okay, reaction of non-metal with dilute acids. So there is a no reaction with dilute dilute acid. Okay, with dilute acid. Okay, and why it is now there is a no formation of any product in this reaction of non-metal with dilute acids because non-metal cannot able to displace non-metal cannot able to displace the hydrogen from the dilute acids dilute acids. Okay, non-metal cannot able to displace the hydrogen from the dilute acids. It means from the acids there, from the acids we need to make any reactions. Then dissociation of hydrogen ions from their acids. So, but non-metals cannot able to displace the hydrogen from the acids. Okay. Third one is sorry. Fourth one, non-metals. Sorry. Reaction of non-metals with salt solution. Salt solution. Okay. Reaction of non-metal with salt solution. Then there is a we have to write no reactions sorry, no reaction, but very highly they can react. So listen, salt solution of more reactive, more reactive salt solution of non-metal can able to able to react with can able to react with less reactive salt solution. Okay, they are telling that it means more reactive salt solution. It means like 2NaBr, that is the sodium bromide, when react with the chlorine and formation of 2NaCl plus Br2. Okay, that means bromine gas will be formed here. Okay. So what is the it is reaction of non-metal with water? No reaction with water, because generally non-metal do not give electron to reduce the hydrogen ions from water, and reaction of non-metal with dilute acids, no reaction with dilute acids, because non-metal cannot able to displace the hydrogen from the dilute acids. Then reaction of non-metal with salt solution, that means salt solution, this is the salt solution of non-metal, because this is the non-metal and this is the salt solution. Okay, with that, so more reactive salt solution of non-metal can able to react with less reactive salt solution, because the more reactive salt solution can easily displace the less reactive salt solution from that. So 2NaBr plus Cl2 and 2NaCl plus Br2. It means with the sodium bromide, when it is react with the chlorine gas, then formation of sodium chloride and bromine gas. Okay. Then fifth number. Okay. Reaction of non-metal with chlorine and sorry, sixth number. Okay. Reaction of metal with hydrogen. Okay. So like non-metal reaction with the chlorine and reaction of non-metal with the hydrogen. So some reactions we can describe here. Okay, and here I think you are understanding. No reaction with water. Generally, non-metal do not give electron to reduce the hydrogen ions from water. Reaction of non-metal with dilute acid, then no reaction with the dilute acid, because non-metal cannot able to displace the hydrogen from the dilute acids. Okay, and reaction of non-metal with salt solution, more reactive salt solution of non-metal can able to react with the less reactive salt solution, and like 2NaBr plus Cl2. Then what will be the reaction of non-metal with the chlorine? With the chlorine. So generally they cannot able to react with that, but I am explaining one example here, like H2 gas. One chocolate. So then reaction of non-metal with chlorine, H2 plus Cl2 and formation of 2HCl. I think you already seen that this reaction, and one more reaction is here, or one more example is here, that is T4 plus 6Cl2, that is 4PCl3. 4PCl3. Okay, I'll explain here. Okay. Reaction of non-metal with hydrogen. So for like that, H2 plus S, then formation of H2S, and one more reaction is that N2 plus 3H2, that is reaction is 2NH3. Okay, so what is the reaction with that? For explaining, I am writing here. Look, okay, okay. Generally, non-metal uh, non-metal form covalent chlorides because non-metal cannot give cannot give electrons to cannot give electrons to chlorine to form chlorides. Okay, and same reaction is that here. This I can explain here. It is. And same reaction is for that here. Look, generally non-metals cannot able to react with the hydrogen, but sometime when they are, it means they cannot able to form hydrides. Okay, so I can write here non-metals cannot able to give electrons to hydrogen to form hydride. Okay, hydrogen. Okay, so they are telling that it means the reaction of non-metal with chlorine. So they are formation the covalent chloride. Okay, it means they are forming the covalent chloride. Chloride are generally non-electrolytes. Okay, and they are the it means formation of the covalent hydrides. Okay, not covalent chlorides, they were formation, not single the chloride. So generally non-metals form covalent chloride because non-metals cannot give electron to chlorine to form chloride. It means purely they cannot able to make a chlorides, they are forming the covalent chlorides, and non-metals cannot able to give electron to hydrogen to form hydrides. So that's why they are formation the covalent hydrides. So they both name as covalent hydride. These are the covalent chloride. I hope you are understanding what I am telling here. Okay, these are the covalent. It means when the reaction of non-metals is with chlorine, then formation of covalent chloride, because generally non-metal form covalent chloride because non-metals cannot give electron to chlorine to form chlorides. Okay, and reaction of non-metal with hydrogen, then always generally formation of the covalent hydrides, and non-metals cannot able to give electron to hydrogen to form hydride. Okay, it means they are not forming the hydrides, they are forming only the covalent hydrides. So these are the name. H2 gas is the rotten egg smell. Okay, and 2NH3 it is the ammonia. You know about the what are the uses of this ammonia. Next our topic is like that. We are just expressing in the simple form the uses of metals and non-metals. Uses of metals and non-metals. Okay, for that, if you know about the non-metals uses, you know about the metals. It means like you know the name of iron, then you can tell iron can be used in bridges. Okay, bridges and many tables and it means doors and many different type of utensils. Okay, it means iron also using in the manufacturing of steel. Okay, Next is like copper. So copper generally used in electrical wires. Then aluminum used in aluminum foil and aluminum railings. Okay, and aluminum doors. And other thing is aluminum also used as a good conductor of heat and electricity. Electricity, that's why used in wire. Okay. Next metal, if you know the names, okay, then you can easily write their uses. Okay, like zirconium and many things are bulletproofing materials and like that. And like non-metals, you know about that, like sulfur. Sulfur is used in vulcanization of rubber, okay, used in gunpowder. Sulfur also used in manufacturing of sulfuric acid. Then non-metal like carbon. So carbon are having allotropes of two, like diamond and graphite. Then graphite, you know about that, using in the pencil and you making the lubrications of machinery parts. And diamond, you know about the in the jewelry purpose. Here also we have to mention gold and silver, okay, and that can be used in ornaments and jewelry purpose. Then next is non-metal, okay, sulfur, okay, over carbon over, and next is like nitrogen, okay, and like ammonia, okay. So nitrogen used to formation of ammonia, okay, that is gas. And sometimes this NPK, so like nitrogen, phosphorus, okay, and they are also formation of the in the fertilizers, okay. So many uses we have to see, and according to some at least 5 to 8 uses you have to write only, okay. If you know the name of non-metals, you can write easily their uses, okay. One more topic we are discussing here, okay. After that, that is the ionic compound and properties of ionic compound. So now, students, we are discussing about the ionic bonds, ionic compounds. It means the how can ionic compounds can be formed by the ionic bonds. Okay. So first is ionic bond. Ionic bond. Generally, the bond is made up of between metals and non-metals. So we have to write it is a bond between metal and non metals, metals and non-metals. Okay. When one when one atom can donate electron to achieve inert gas, achieve inert gas configurations, and other atoms other atoms can gain electron to form inert gas configurations. Then formation of ionic bond. Ionic bond. Ionic bond formation ionic bond formed by transfer of transfer of electrons by metal to non-metal. Then it is the ionic ionic compound. Ionic compound. Okay. By exchanging a compound which is formed by exchanging of ions or by ionic bond is ionic compound. It is a strong strong force of attraction in between cation and anion. Okay. So let should we see ionic bond. So it is a bond between the metals and non-metals. So generally in between the metal and non-metal there is a formation of ionic bond. And you know about that bond is a two types, covalent bond and ionic bond. Covalent bond is formation in the like carbon, okay, and other those are having the metalloids also they are forming. But when there is a purely exchanging of electrons, it means when metals can donate the electrons and non-metals can able to gain the electrons to fulfill their vacant shells. Okay. So when one atom can donate electrons to achieve inert gas configuration and other atoms can gain electron to form inert gas configuration. So I hope you already studied these things in the ninth class. Okay. So roughly I am making only the small one things for that. Like sodium, there is a in between them there is a nucleus. Okay, in the sodium atom. Just this is the K shell. Okay, this is the L shell and this is the M shell. Okay, so you know about that. Innermost shell contains the 2 electrons. Out. This is the second L contains the 8 electrons. 4, 5, 6, 7, and 8. And this is here it is a 2. Okay, so this is the valence shell contains the valence 2 electrons. Sorry for like sodium, we are having only 1 electron. This is for magnesium. Okay. So in the M shell there is only 1 electrons in the outermost valence shell. So this is known as now this is the Na. Okay, but when the this electron is just passes through to the non-metals. Okay, so now it can be converted into the Na plus because now there is a lack of 1 electron, and when this electron is goes to the you see the this is the nucleus inside and this is the innermost shell of the chlorine. Okay, this is the chlorine neutral atom. This is one more shell is there. Then they, here is a 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, one more it is here, and this is the 1, 2, 3, 4, 5, 6, and 7. And last one is a, here it is a gap. Okay, here it is a gap for that. So this is the chlorine atom structure. But when this electron is filled in this, sorry, in this one vacant shell, then here it is a formation of chlorine. It means chlorine to chlorine, because here in the because look here, this is the sodium neutral atom. One outermost electron, when it can donate or transfer to the non-metals, it means this is the electron. Then after donating the electrons, it can be converted into the Na plus. Okay, it is Na plus because there is a loss of one electron. There is a loss of one electron, and when this electron goes to the vacant one valence shell of this vacant place of this electron in the valence shell, then the formation of initially it is a neutral atom, that is the chlorine atom, and now with the taking of this electron, it is converted into the chlorine atom. Okay, so now when the reaction of this sodium ion and this chloride ion, okay, like Na plus and plus Cl minus, then formation of NaCl, then formation of NaCl. Okay, so this is our ionic. Okay, first of thing, this is the strong force of attraction of ionic bond. This is a strong force of attraction of ionic bond, and formation of this is the ionic compound. This is formation of ionic compound. And you also see in the 9th class that ionic bond generally formation with the exchange of ions, and covalent compounds can be formed with the only the sharing of the electrons, only sharing of them. It means here it is either gaining or maybe the losing of the electrons, but in the covalent compound only the electron sharing can in between the atoms to each other. Okay, so this is the one general idea to explain how the electronic configurations, and you know about that. Before that, we have to see when one atoms can donate electrons to achieve inert gas configuration. It means when they are donating these electrons, initially they are having the 2-8-1 structure, but when they are giving the electron, then Na plus contains the 2-8 structure. Okay, it means they are having the inert gas configuration now. Initially Cl, it means Cl having the 2, 8 and 7 structure. Okay, 2, 8, 8, 7. But when they are converting into Cl minus, it means now they are having the electrons of like 2, 8, 8, which is a stable configuration. Which is a stable configuration. So look, it means when one atom can donate electrons to achieve, they already, it means sodium already given electron and get achieve this inert gas configuration, and other atoms can gain electron. It means Cl already gain one electron. This atom. So in this way we have to see how can then formation of this ionic compound. It means 281, then formation of 28, and this is the 288. This is electronic gas inert gas configuration. So then because this is the 28, this is the neon configuration, and this 288, that the organ gas configuration. So they both are the inert gas. So that's why we are telling. Ionic bond formed by the transfer of electrons by metal to non-metals. So this is the metals and the transfer of electrons to non-metals. Then ionic compound, it means ionic compound means formation with the ionic bond. Okay, so the compound which is formed by exchanging of ions and by ionic bond or by ionic bond. It means the compound which is formed by the ionic bond is known as ionic compound, and it is a strong force of attraction between the cation and anion. You know about that, cation is a positive ion and anion is a negative ion. Okay, and some more example we have to see here for this. Then we have to look that like Na plus, then Cl minus, then formation of NaCl. Okay, then Mg2 plus and 2O minus, then formation of MgO. Okay, then formation of like MgCl2, then Mg plus 2Cl minus, because here there is a then Mg Cl2, okay, 2Cl minus, and Mg also 2 plus. So these are the ionic compounds can be formed by the ionic bonds. Okay, and one more explanation I can do for you. Listen. For that, it means how the atoms can form this reaction. So, like Mg and 2HCl. Okay, because Mg having two outermost electrons in their valence shells, and Cl contain one vacant place, and this Cl also contain one vacant place. You already seen that. So one outermost electron goes to here and one outermost goes to here. Then it is a 2 plus charge. Okay, and this is minus and this is negative. Then formation of Mg 2 plus and 2 Cl minus. That's why formation of MgCl2. Okay, MgCl2. Okay, so you know about that. It is a easy things, and you already seen in ninth class. Okay, now we have to discuss about the ionic compounds properties. Now, students, we are discussing about the properties of ionic compounds. Okay, so properties of ionic compound. Properties of ionic compound. So we already discussed about that. What is ionic bond and what is ionic compound. Now, what are the main properties of this ionic compound? So first property is ionic compounds are generally crystalline solid. Okay. Second property is ionic compounds are high melting point and boiling point. You have to listen or you have to remember this 2, 3, 4 properties. Okay, these are the important properties for you. Okay. And ionic compounds are but insoluble in organic solvents like benzene, carbon disulfide means CS2, kerosene, ether, acetone, like that. Okay, and fourth is ionic compounds conducts electricity. Listen. Properties of ionic compound means ionic compounds are generally crystalline solids. So we will see the what are the reason for that for everything. And but first of you know what are the meaning or means of these properties. Ionic compounds are generally crystalline solids. Generally crystalline solids. They are forming the solid structure. They are having a high melting point and high boiling point. They can able to soluble in water but insoluble in organic solvents like benzene, carbon disulfide, kerosene, ether, acetone. Okay, and ionic compounds conduct electricity. So, what are the reasons for that? Now we are discussing. Okay. Ionic compounds are generally crystalline structure because they form by the ionic bond, and this this form solid structure due to strong force of attractions. Okay, they formed by the ionic bond, and you know about that ionic compounds are generally formation by the strong force of attraction in between the ions. Strong force of because due to strong force of attractions between ions. Okay, like NaCl. Okay, sodium chloride is a generally crystalline solid. Okay. Then ionic compounds are generally having a high melting point and boiling point, like sodium having melting point 800 degrees Celsius and boiling point 1413 degree Celsius. It means they are having a high melting point and boiling point because because extra more uh, heat energy needs to break the force of attractions of ions. Okay, it means sodium having a melting point like 800 degrees Celsius and boiling point contain 1413 degrees Celsius, because extra more heat energy. It means too much extra heat energy is need to break the force of attraction of ions. That's why they are having a high melting point and boiling points. Like generally soluble in water uh, because water is dielectric. What is dielectric? Constant and universal solvent in which water can able to soluble the ionic compound. It means the ionic bond which can be easily break in the presence of water. Like that, when some NaCl, when we are soluble, make them soluble with the water, then there is a formation of different type of ions. It means just lose the ions. It means they are dissociate the ions, but lose their concentrated solution. Okay, so it means that when the when this when this ionic compounds we make soluble in water, then formation due to the water is a dielectric constant. It means they are having the two type of electric constant, and due to the universal solvent is also, and water, that's why can able to dissolve the ionic compound. Okay. And last is ionic compounds conduct electricity. You know about that. Those are having dissociation their ions in the container. You already seen that. So like NaCl. So they just dissociate ions. They can able to conduct electricity. Okay. So ionic uh, dissociation. Ionic dissociation easily can be able in ionic compounds. It means those are easily can dissociate their ions. They are a good conductor of electricity. It means they can form the electrolytes. They can able to form the electrolytes. Okay. So these are the four properties of ionic compounds. Okay. And I hope you can able to understand these properties, four properties. So after this, we are just finishing this chapter now, okay? Because the some more later parts are like the uses, like extraction of minerals, and which not in our syllabus now this time. Okay. So thank you.